In this podcast, you'll learn about the essentially very simple problem of calculating percent yield. But we're going to tack on that simplicity to a problem that involves mass. Now, to be able to do this PowerPoint, you're going to need your yellow PowerPoint notes, and you're going to need this worksheet that says percent yield practice sheet on the front and percent yield worksheet on the back. You're also going to need a periodic table and a calculator because you'll be needing to calculate some molar masses. And by the way, I don't know if he shows up, but in the background you might see a cat fort. And if it starts moving, don't get worried. My cat Midnight is asleep in the fort and might come springing out. Now, percent yield is calculated very simply. You simply take the actual yield that you measured in a lab in an imperfect situation and divide it by the maximum amount of product, or the theoretical yield, that you would have gotten if you were a perfect person and you didn't make any mistakes. What might be a mistake? You accidentally poured some of your silver down the drain, or maybe some of your silver got left on a piece of filter paper. It's a way to measure how efficient you are as a chemist. And of course, our goal is to try to get 100% yield, not to lose anything due to human error. The actual yield on top is always going to be smaller than the theoretical yield. And another way to think of the theoretical is, what would you have made if you were a perfect person that didn't ever make any mistakes? The actual yield you will either measure in a real live lab, or you'll be always given the actual yield in the problem. And both of these yields, by the way, are in grams. So let's do a sample problem. Let's go to the percent yield practice sheet, of which you can see a screenshot here. This is as simple as these problems can get. I almost never give you these, they're too simple. They tell me that the theoretical yield is 45.42 grams, and the actual yield is only 36.25. Unless you are an omnipotent being, you cannot create more matter from what you started with, so the actual yield is always less than the theoretical yield. Unless you didn't dry your copper or your silver properly and there was still some water in it. I'm referring to the labs we've done recently. So I'm not actually going to solve this problem because every one of you can divide 36.25 by 45.42 grams of water, times it by 100, and get the percent yield. Shortcut, when you multiply by 100, remember you'll be able to move the decimal place 2 points or 2 places to the right. Now here's that second problem on the worksheet. Now it starts to get a little challenging. Your first step is always to balance an equation. And a quick look at the far right is telling me it's balanced. I have a calcium, 2 hydrogens, and 2 oxygens, both on the left and on the right. But what's confusing is we tried to trick you by putting 140 grams of calcium oxide and 140 grams of calcium hydroxide. So the hint to find the 140 grams of the actual yield is look for keywords like produced or yields or is made. And percent yield problems always give you the actual yield, because here it is, 140 grams is produced. So I would recommend that you circle that, label it, write actual by it, and forget about it till later, because you have to do a mass problem with 140 grams of calcium oxide to find the theoretical yield if you were a perfect person. So we've been given our actual yield. Now to get a theoretical yield, almost always we make you do a mass problem. Remember, mass problems, you write what you know. In this case, reactant, calcium oxide, I was given 140 grams. I have to turn that into grams of calcium hydroxide. So if I have to turn it into grams of calcium hydroxide and I was given grams of calcium oxide, draw 3 times bars, our conversion factors. Now remember, when you put all the units in first, don't put any numbers in until the end. My way or the highway. If you do it this way, you'll always get your numbers in the right spot and not get the inverse of the correct conversion factor. So here's my start. Reactant is given, calcium oxide. Here is my end. I have to get theoretical grams of calcium hydroxide. So remember we said, if you have grams of calcium oxide, put it on the denominator of the next value so that you can make sure that they cancel. If a problem gives grams of calcium oxide, your compulsive reaction is to turn it into moles of calcium oxide. Then compulsively draw that again on the denominator of the next conversion bar so that you know that it will cancel. Now I have to go a little bit backwards. I'm going to put grams of calcium hydroxide, what I'm solving for, on the last bar. And notice that before you could ever get grams of a substance, the previous value must say moles of that substance, which I automatically draw down here. Notice that in the middle is a molar ratio, which comes from the balance equation. I like this equation because this makes it easy. It's 1 to 1. 1 calcium oxide makes 1 calcium hydroxide. And notice that the first conversion factor is the molar mass of calcium oxide, and the third conversion factor on the far right is the molar mass of calcium hydroxide. Remember, if you get confused, is it moles on top and grams on the bottom? Start with what you know you were given, grams of calcium oxide, and then you'll know that the grams of calcium oxide goes on the bottom, and in any molar mass, the number that always goes with the word moles is 1. So now, put in all the numbers. Well, that wasn't too tough for me because all the numbers I had to put in were 1, but you got lucky because here at the heart of the problem, there is a 1 to 1 ratio. And notice that when we're done, all of the units will cancel except for the units of calcium hydroxide that we need to solve for. Now there's a limit to my generosity, so you are going to have to calculate from a periodic table the molar masses of CaOH2 and the molar mass of CaO. But when you are done putting those numbers into the spot where the question marks are, now you have the theoretical mass of calcium hydroxide that you would have made if you hadn't made any mistakes in a perfect world. You have to take it from here. Take your actual yield of calcium hydroxide, divide it by what you've just calculated, theoretical yield, times it by 100, or take the shortcut of moving the decimal point 2 places to the right, and make sure that you show all of your work clearly, as well as circle or box in your answer so that is also clear. I would recommend that you use question number 2 on this worksheet as a guide to solve number 3. Same problem, just different substances and numbers. This time it will not be a 1 to 1 ratio. Make sure that the next time I see you, the sheet is complete so you can get the completion stamp. And if you have time and you know when the backside percent yield worksheet is due, you can start solving those problems. These ones will be graded with accuracy, so be sure to check in with your teacher for the correct due date. One last time, let's do a sample problem. Potassium chloride is the product that we're looking at here. You can make potassium chloride when you react potassium carbonate with some hydrochloric acid. So we've been given the actual yield of potassium chloride. This problem is going to be about KCl. But we'll have to start with balancing the equation first. So no easy 1 to 1 ratio anymore. Now we have our actual yield and a balanced equation. Step into mass-mass mindset and start with 45.8 grams of K2CO3. That is what we call the entry grams. So that will be found by writing what I know, 45.8 grams of K2CO3, followed by 3 conversion factors. Now the way that this particular PowerPoint slide is set up, they're shooting in the numbers there before we have a chance to put the units, but always units first. That way you won't get things upside down. The only thing that makes this problem different is we have different substances with different molar masses, and now you got to do a little work because it's a 2 to 1 ratio. Make sure you understand what that means. For every 1 mole of potassium carbonate, you'll make twice the number of moles of KCl. These molar ratios only work for moles, though. They never work for grams. So even if you started with 45.8 grams of potassium carbonate, that doesn't mean that you're going to make twice that amount, 91.6 grams of KCl. First, you have to find the moles of potassium carbonate, and in a perfect world, you'll be making twice the number of moles of KCl. So when we're done crunching our numbers, that was a lot of work. And at first you go, oh, thank God I'm done. But that's not the done part. That is just the theoretical yield. So now we have our actual yield. We have our theoretical yield. You divide. The actual is always smaller than the theoretical, and you multiply by 100 to turn that into a percent. Or shortcut, move the decimal point 2 places. So that's pretty good percent yield on 93.7. At this point, I will stop the vodcast, and you can go to work on any percent yield problems that your teacher has assigned you. Take care.